In this part of the Computational Intelligence course related to fuzzy systems, we continue with fuzzy controllers. We will examine approximate reasoning with disjunctive and also with conjunctive fuzzy rules.
The fuzzy control rules may be in the form, for example, if temperature is very high and pressure is slightly low, then heat change should be slightly negative. Or it may be in the form, if rate of descent is positive big and airspeed is negative big and glide slope is positive big, then revolution per minute change is positive big and elevator angle change is insignificant change. In approximate reasoning with fuzzy rules, the general schema of rules are as follows. Rule 1 is saying that if x is m1, then y is n1. Rule 2 is saying that if x is m2, then y is n2. We go up the rule r, and this is saying that if x is mr, then y is nr. We have a fact saying that x is m prime. And by using these R rules and the fact, we have the conclusion saying that y is n prime. Given R of if-then rules and the fact that x is n prime, we conclude that y is n prime. These are typically used in fuzzy controllers. If we have disjunctive imprecise rule, then this imprecise rule may be saying that if x is belonging to the interval 3, 4, this is called the interval m, and then y is the interval 5, 6. So this is saying that if x is m, then y is n. The interpretation is that the values coming from the interval 3, 4, Cartesian product with the interval 5, 6, we have a solution in this region. If then rule is saying that if x is in this region, then y is in this region. So we have a solution which is the Cartesian product of the region 3, 4 with 5, 6. If we have more than one disjunctive imprecise rule, then we have several if x m1, then y n1. If x m2, then y is n2. If x is m3, then y is n3, etc. Suppose that we have these three rules. The interpretation is like that. Rule 1 as well as rule 2 as well as rule 3 hold true. So if we take the Cartesian product generated by each rule, for rule 1 this is the solution region, for rule 2 this is the solution region, and for rule 3 this part is the solution region. So as the solution we take the union over I from 1 to R, we take the Cartesian product of mi and I. The patchwork is describing function's behavior as indicator function. So for each this region, for this gray region, the membership value is assumed to be 1 because these regions are described as crisp regions. To find the solution when input is x0, this is the fact, then we apply composition of x0, this is the value of x, with the solution, then we obtain a solution for the output value. So here this gray region is corresponding to the possible values, and so the value of y can be a value in this interval. Now both x and y are fuzzy sets. This is a single fuzzy rule, and this is saying that if x is nm, for example, then y is ps, negative medium. If x is negative medium, then y is positive small, for example. For this set, we have a membership function, and for that one, we have a membership function. And if we consider this region, instead of an indicator function having value 1 everywhere, we have a fuzzy relation in this region. So that relation is the membership on the reference set X, and here we have the membership N for Y, and we apply the cross product of these two, we obtain such a fuzzy relation. If we have several fuzzy rules saying that if x is negative small, then y is negative small. This is shown as n prime because it is on y. And for example, if x is approximately 0, then y is approximately 0 prime. And if x is positive small, then y is positive small prime. So these are the fuzzy membership functions for negative small, approximately 0, and positive small. We have fuzzy sets here for each of them. And here we have the fuzzy sets for n negative small, n approximately 0, n positive small. So we have these fuzzy sets. These are the membership functions. Then the relation is the Cartesian product as the given here as a rule. Membership negative small, and this is for x, and the membership n negative small prime. And for each Cartesian product, we take the union of them to obtain the relation. So the union of these relations corresponding to each rule is corresponding to collection of several rules. So, for example, consider this example. Here we have 3 rules. In fact, in 3 dimensions, each rule is saying that, for example, if x is negative small, then y is negative small. So this is the corresponding relation. This is the Cartesian product of these two. And for this one, the rule is saying that if x is approximate 0, y is approximate 0. This is the corresponding relation. And this is the relation for the third rule. And if we take the union, it is the union of these relations. And suppose that the value of x is x0. So this is corresponding to the fact. And we have to take the composition of x0 with the relation, it is that relation, union of these 3. And if we use the value x0, here, if we take the composition with the relation, so we obtain such a shape. And its projection on the y-axis is given here. So this is corresponding to the conclusion. Notice that this information is fuzzy. We have 3 fuzzy rules. Every pyramid is specified by one fuzzy rule, that is Cartesian product. Input x0 leads to gray shaded fuzzy output, which is x0 composition R. Fuzzy relation R employed in reasoning is obtained as follows. For each rule I, we determine the relation Ri by the relation Ri. For x, y, we are taking the minimum of the membership function mi at x and the membership ni on y, and we take the minimum of these two values for all x element of x and y element of y. Then R is defined by union of Ri, union of the relations representing the rules, that is union of I from 1 to R, union of R, I. That is, if we are using this formula, if then rules are treated disjunctive. If it is the case, if then rules are conjunctive, it can also be treated, but in that case, instead of union of the relations, we have to take the intersection of the relations. Decisions depends on intended use and how Ri are obtained. For disjunctive and conjunctive form, we have 2 possible ways of applying compositions. We may either apply the composition with the fact A prime. We are taking the composition with the union of the relations representing each rule. First we take the union and then we apply the composition. Or for each rule, we apply the composition and we are then finding what is the union. Both can be used for finding the solution for the disjunctive form. For the conjunctive form, we may either first take the intersection of the relations representing the unions, and then we apply composition with the fact to find the solution. Or for each rule, we find out what is the composition and then we find out what is the intersection of these compositions. If we have conjunctive imprecise rules, for example, if x is belonging to interval 3, 4, then y is belonging to interval 5, 6. The gray shaded values are impossible and white ones are possible. Here notice that we can describe this white area as Cartesian product of 3, 4 and 5, 6, it is this region. And also we take the complement of this region. It is the region, x is not in the region 3, 4. And then we take the Cartesian product with all the reference set y. So we have additionally this region and also this region. If we have several rules, several conjunctive imprecise rules. If x is m1, then y is m1. If x is m2, then y is n2. If x is m3 and y is n3, then for each rule, we find such a region, and after that, we find what is the intersection. This is the corridor describing functions behavior. For each rule given here, we are considering the Cartesian product mi Cartesian ni, and we are taking the union with the complement of mi and Cartesian product with the whole reference set y. And for each rule we have such a union, and then we take the intersection I from 1 to r. This is the number of rules. And if we have given a fact saying that x is x0, then we apply composition with the fact and the relation to find out what is the output. So here we have such a region which is possible. So this is the possible output region. Here the sets M1 and 1 are crisp, that is membership value is 1. However, we will consider also fuzzy membership.